Dear students, today we are discussing about some applications of trigonometry. So far, we have studied trigonometrical ratios, reciprocal relations, division rules, and some of the identities, trigonometrical identities. Now, the part of trigonometry where we can apply in day-to-day life. So the chapter number 9 of your textbook is some applications of trigonometry. Some applications of trigonometry. But here in this, usually we are going to study about heights and distances. Heights and distances. So in the class 10, we have some applications of heights and distances. But before discussing heights and distances, let me clear this idea for you. Sin theta, we know that are opposite by hypotenuse, and cos theta adjacent by hypotenuse. And dear students, then tan theta is equal to opposite by adjacent. The fundamental basic ratios of trigonometric functions we have discussed. Look at this, observe the name of the topic here clearly, my dear students. Heights and distances. That means this is height and this is distance. So this is height and distance. Suppose if I draw the hypotenuse, the name of the topic is heights and distances. That is opposite side and adjacent side. So in most of the cases, we are not using hypotenuse. Therefore, the name of the topic is height stands for opposite, distance stands for adjacent. Opposite and we are just means the entire topic is depends on opposite side and adjacent side. So opposite and adjacent where you get in the tan. Therefore, most of the cases, 99%, we use only tan, because the chapter itself says it is height. Height means opposite, and adjacent side means distance. The name of the chapter itself tells us that only we require opposite and adjacent. So opposite and adjacent, see, sine is of no use. Why? Because here hypotenuse comes. Cos is also of no use for me. Here also hypotenuse comes. For me, only two items are required. One is height and other one is distance. So distance means adjacent. Opposite and adjacent comes in only tan. So therefore, in heights and distance topic, we use only tan theta definition. Tan theta means opposite by adjacent. Opposite is also known as height and adjacent is known as distance. But I'm telling you, of course, as per the name of the topic I have defined, but wherever some cases, I told you, this one is 99% we use, In 1%, sometimes we may use hypotenuse also. We may use hypotenuse also. But wherever hypotenuse comes, either you can use sine or cos. As per the situation, we use either sine or cos. That depends upon the problem. We decide. Now, dear children, but when you are using tan, definitely cot also applicable. You can also apply cot also, adjacent by opposite. That is distance divided by height. So the name of the chapter itself is heights and distance. So that means entire topic is depends on opposite and adjacent. Opposite and adjacent. Therefore, opposite and adjacent comes in only tan. Therefore, to study heights and distances, we use only tan theta definition. To study heights and distances, we use only tan theta. Tan theta reciprocal means when you are using tan, automatically you are using cot. So, to study heights and distance, what is basic? First we should know. What are the basic? We have to understand the basic part. What is the basic fundamentals we must have before solving the problems? Dear students, look at, usually the straight eyesight, listen, the straight eyesight, this is called, always we call it as line of sight. This is called line of sight. But here, if suppose there is an object on the top of your line, straight eyesight, that is straight eyesight, it is straight eyesight. Suppose from here, this is the point, we can call it as O. To observe point A, you'll have to lift your eye. You'll have to lift your eye. That is here, from here, that is called. You have to lift your eye to, correct? Or you have to lift your head. From straight eyesight, you want to see up. So whenever straight eyesight up, if you see, this angle is called angle of elevation. Angle of elevation. Or usually angle of elevation is also known as positive angle. Very simple. See, look at it. When the straight eyesight, if up, that angle is going to be called as angle of elevation. Suppose, dear students, once again, I'll tell you, this is straight eyesight. This is straight eyesight. That is straight eyesight. Suppose, see, bottom there is again some B is the object. This person, to watch B, you have to, so that is a straight eyesight. Below there is an object, he has to bend his, or he has to bend his head, or bend down his head, or he has to tilt his eyes down. That means here, this will be again, from here, you will see like this. To see this one. So this angle is known as angle of depression. Straight eyesight below, look at it. Straight eyesight up is called elevation. Straight eyesight below is called angle of depression. Angle of depression. So usually you will be having 4 marks question. So very simple. Again, I'm telling you. But here what happened? Heights and distance. The trigonometry will be used to find out heights of larger items like height of Mount Everest. So when you are measuring the height of Mount Everest, the person's height, the body, the observer height is maximum 5 feet or 6 feet. Whether it is added or subtracted doesn't make any difference. That is. So first, straight eyesight up. Straight eyesight up, the angle is called angle of elevation. Elevation means up. And straight eyesight below, the angle, whatever angle it is formed, that is going to be called as angle of depression. Usually, angle of depression is called, we call it as a negative angle also. But before solving any example, my dear students, before solving any example, remember, whether you are standing on the top of the hill, you assume that you are standing on the top of the hill. First, on the top of the hill, you first go and make your line of sight is straight first. From there, next process starts. Again, if you are looking up, from the straight eyesight only, you have to measure the angle. From the top of the hill, you are looking down. From the top of the house, from the top of the hill, you first go and make your line of sight straight first. From there, if you are looking up, that is elevation. From there, if you are looking down, that is called angle of depression. So here, the observer, the person who is going to measure the height and distance, his height, maximum average, it is 5 to 6 feet height. So when you are, when you are measuring height of the Mount Everest, in that Mount Everest height, the person's height, whether it is added or subtracted, it doesn't make any big difference. We are measuring the depth of the ocean. In the depth of the ocean, 3 feet, 4 feet, 5 feet, plus or minus doesn't make any difference. Therefore, we always in the problems, we take only eyesight only important. Line of sight is important. We don't bother about the person's, this is the person here. So we don't bother about his height of the person, is not at all bothered. So this is the basic one must know before going to solve any problems on heights and distances. So let me once again, before going to start the problems, the name of the chapter is height and distance. That means the chapter itself is we want opposite and adjacent. Opposite and adjacent comes in only tan. Therefore, in our most of the cases, somewhere, wherever hypotenuse is necessary, suppose sometimes if the hypotenuse is necessary, definitely we'll apply sine and cos. Therefore, tan is the only ratio we'll apply. So when you are applying a tan, there is no need to apply cot. So once again, before solving the problems, straight eyesight up is known as angle of elevation. Straight eyesight below is angle of depression. Okay. Let me start from your textbook examples only first. So first I'll start some problems from your textbook. Dear students, let me go through with the problem now first. The first example. So this is so angle of elevation, angle of depression. Exercise 9.1. Exercise 9.1. So let me start with the problem here. So here the problem first I'll write and afterwards. A tree breaks. A tree breaks due to storm. Due to storm. And the broken part bends so that bends so that the top of the tree, the top of the tree touches the ground, making an angle 30 degrees, making an angle 30 degrees with it. The distance between the foot of the tree, to the point where the top touches the ground, is 8 meters. Find the height of the tree. Look at my dear students. Really very interesting problem. Read once again for you. A tree breaks due to storm and the broken part bends so that the top of the tree touches the ground, making an angle 30 degrees with it. The distance between the foot of the tree to the point where the top touches the ground is 8 meters. Find the height of the tree. Okay, first we'll draw one rough sketch. We'll come to know. Look at it. So first we consider here, it is the level ground. We just think that this is the level ground. And here the tree is, so here this is the total tree. Suppose here you can take this one is the total tree here. Somewhere it is the total tree. Now look at here. This is the tree. So here, this is the tree. This is the tree. A tree breaks down due to storm and broken part bends so that, so here tree is broken here somewhere. That is called, suppose this is called level ground. So B, this is the part is C, BC is the total tree. And here it is, dear students, remember it is the broken here, it breaks. And this part CD will fall on the ground now. That is C will come touch here. Look at it. Look at this. At D, here the break point. So it breaks and this part is not totally detached. So C part will fall down here. That is once again here. Look at here. This is here. The C part, that is after breaking this portion. This portion Dear students, now see, this is one. At D, it breaks and it falls down like this. Then that is, after that, here it will C will come here. See the one. Now C is here now. C is here. So then now, what is the height of the tree now? Height of the tree is, height of the tree, come on, tell me now. Because see, here it breaks and C will fall here. C will fall here. That is equal to CD plus height of the tree is what? CD plus BD. CD plus BD. Height of the tree is CD plus BD. CD, look at here. This is C. CD plus BD. Now, a tree breaks due to storm. At D point here it breaks. After breaking, the C will collapse here. From this direction, wind is coming this direction. So it will fall down. So that the top of the tree, that is, this is the top of the tree now. Top of the tree touches the ground, making an angle 30 degrees with it. Here it is making an angle 30 degrees. The distance between the foot of the tree here, this is the foot of the tree, to the point where the top touches, this distance is given 8 meters. 8 meters. Height of the tree is already, we know that CD plus BD. So now first what we'll do, we'll apply from this triangle tan 30 so that we get BD. Afterwards, Pythagoras theorem, we need CD also we need. Because CD plus BD is our answer now. Height of the tree means what? CD here. Yes, CD plus DB. That of course, this portion has fallen down because here it is. Totally it has fallen down. So from right angle triangle, what is tan 30 from the right angle triangle? Tan 30, why I am applying? Because we want height means we have height of the tree means we are depending on two factors. One is we need BD plus CD. After adding these two only, we'll get height of the tree. So the top of this one touching the ground. Look at first. What is the use of, I'm applying tan 30. Tan 30 is equal to, in this triangle, opposite by hypotenuse, so that I'll get BD. First BD I'll get. Next we'll plan for CD. So tan 30 definition is BD upon BC, that is equal to 8 meters. BD is equal to 8 into tan 30. We know that tan 30 value, tan 30 degrees is equal to 1 by root 3. So BD is equal to 8 into 1 by root 3. It will become 8 by root 3 meters. So we got BD now. Total height of the tree is asking, including broken part. So BD means this is the, yes. Now CD I will get. CD means hypotenuse. Now we see that hypotenuse is equal to, that is equal to, after breaking down, this is the tree, height of the tree will become 8 by root 3 meters. But total height of the tree, including broken part, that is CD is required. How will you find out CD? So here clearly the CD stands for hypotenuse. Hypotenuse means you can apply Pythagoras theorem also, because we can apply CD square. In this case, CD square Pythagoras theorem we can apply, because this is 8 by root 3. We got it. Already we know that height of the tree is what? Height of the tree. Height of tree is equal to, we know BD now, we want only CD now. Or else you can apply a sine or cos, any one definition you can apply. Or cos 30 I'll apply. Once again, this right angle triangle, cos 30. Cos 30 degrees is equal to adjacent by here. 8 divided by hypotenuse CD. Correct? In this triangle cos 30, 30 means adjacent by hypotenuse. We want CD, cross multiplication. You just bring CD left side top and 8 by cos 30. But you must be aware of that. Cos 30 degrees is equal to root 3 by 2. Can apply. CD is equal to 8 by root 3 by 2. 2 goes to that is equal to 16 root 3 meters. So already we have studied that height of the tree is equal to height of the tree is equal to, already we have studied, BD plus CD. Look at it. So height of the tree means what here? Here clearly I'll say that here. Height of the tree means what here? CD plus BD. So already BD we got it what? BD is equal to 8 by root 3. 8 by root 3. Plus CD just now we got it 16 by root 3. That is equal to 16 plus 8, 24. 24 by root 3. Still you can simplify it here. 24 can be written as 8 into root 3 into root 3. That is equal to root 3 into root 3, 3. 8 3 is a 24 by root 3. And root 3 get cancelled. The total height of the tree is equal to 8 root 3 meters. The total height of the tree is equal to 8 root 3 meters. 8 root 3 meters. Dear friends, so this is what we need to study now. So today just let me, because these all with the diagram, in the next class with the diagram systematically will advance. I'll draw the diagrams and come. This is also, I think you'll be having 4 marks example. So very systematically you study this. Most useful item in engineering. For example, Titanic movie. After 70 years, Titanic movie has been identified in the ocean, bed of the ocean, by using trigonometry only. So that's what, once again, we'll try to approach this systematically. In the next class, I will just solve tough examples. Thank you, my dear students.